Alrighty, folks, section 1.2 is kind of definition heavy, so bear with me. We're going to get through it together. The first part, starting off with definition number 1, end behavior. Now, I'm going to use some pretty, kind of not so technical language here, but hopefully it'll make sense. So, we're going to say end behavior is what the graph does. There's more to it. So, what the graph does as it goes to the left, and before we go any further, we will be going to the right as well, but I want to talk about what it means to go to the left. So left and right, thinking about a graph, if we're going to the left, I got to think about how to do this backwards. Oh, that's your left. So as you're going to the left, so this way for you, looking at the screen, the graph is going to the left on the horizontal axis, which is the x-axis, and it's going further and further to the negative. So we're going to say, we're going to draw an x, because we're talking about the x-axis, and we're going to say as x approaches negative infinity. Because as the graph goes further and further and further to the left, it's getting closer and closer to negative infinity. Now, you can't really achieve infinity regardless of what Buzz Lightyear says about to infinity and beyond. You can't get to it, much less beyond it. But we're going to say it approaches negative infinity. So I'll even put that as x approaches. I skipped a little bit. There we go. Let me just rewrite that word. X approaches, A-P-P-R-O-A-C-H-E-S. There we go. Negative infinity. Gotta get used to this whole teaching thing again. So x approaches negative infinity. So we're going to say as x goes to the left, that means it's going towards negative infinity. And we're going to say and to the right. Putting this in context, so for x going to the left, we said x approaches negative infinity. For x going to the right, we're going to say x approaches positive infinity. Now, technically, you don't need the positive sign there, but just to kind of help us distinguish between the two, we're going to use the positive symbol. A turning point. We're going to say, pardon me, it's where the graph changes directions. And I'm going to leave it a little broad like that because it can mean several different things depending on what you're talking about. So it's where the graph changes directions. A local maximum. We're going to say it's the highest point within a set domain. Now, thinking back to the word domain. Domain means between what x values. So it's describing what x value you can use. So if a local max is the highest point within a domain, it might not be the highest point on the overall graph, but it might just be the highest point in this small area. It's kind of like you can describe what the tallest mountain is in the United States, but that's not the tallest point in the world. Yeah, never mind. I was going to get into the details of that, but I don't remember which the highest or the tallest mountain in the United States is. It's Mount McKinley or Denali. There we go. That's the term now. Anyways, that's besides the point. Local minimum. Well, I bet you can't guess this. We're going to say it's the lowest point in a domain. So local max, highest point. Local min is the lowest point within a domain. And again, I'm going to just describe domain as a set of x values. So what's the highest point between x equals 0 and x equals 30? Something like that. Increasing and decreasing intervals. Increasing intervals, we're going to say it's got a positive slope between 2 points. For a decreasing interval, we're going to say that's got a negative slope. Between 2 points. So increasing, we're talking about where it's got a positive slope. And remember, we're talking about slope, we're talking about as it goes from the left, this is your left when you're looking at me, from the left to the right. So that's got a positive slope, but if it was going the other way, that would have a negative slope. All right. Couple more definitions, and always remember in these videos, feel free to pause if you need a few more moments to get some definitions down, or if we're working on problems and you're just stuck on something, or you just need a few more seconds, you can always pause the video and come back to it. Moving on to symmetry. We're going to focus on one specific type of symmetry for this section. We're not going to use all the types of symmetry that you may have learned about in geometry. We're going to focus mostly on reflection. So we're going to say half of the graph, which is just a fun phrase to say because it rhymes, half of the graph can be reflected onto the other. Now, again, I realize that in geometry, you dealt with various types of symmetry. You dealt with reflection, like we're talking about here. But you also dealt with rotational. You also dealt with, well, it's probably, I think those are the two you might have focused on. So we're not going to be using rotational for now. We're just going to focus on reflection. So for example, if you have a quadratic graph, like you were looking at yesterday, they can reflect on top of each other. So it's symmetrical if we're just doing like a parent graph here. It's symmetrical, and we'll talk about like over what axis. We'll talk about the axes later. Average rate of change. It is the slope between 2 points. Skipped a letter, sorry. Now, when we're talking about slope between 2 points, we might be talking about a graph that goes through a bunch of curves. But we could be talking about the average rate of change from that point to that point, and we would end up just calculating the slope of that little segment there. We wouldn't necessarily need to calculate every single slope along here because that's a little bit of calculus. We're not quite ready for that. We'll get to that later though. Intercepts. Intercepts are where the graph touches the axes. And let's be a little more specific. So where the graph touches the x-axis and slash or, because it doesn't always have to touch both, but and or the y-axis. Sometimes you get a graph that touches only the y-axis but never touches the x-axis, or sometimes it touches both. Yeah. Domain. We kind of talked about that one a little bit earlier, but that is all possible inputs. Now, thinking back to when you probably first learned about domain, all possible inputs, you probably just thought about the x values. The reason I'm not saying just the x values or all possible x values is because you're not always going to be dealing with x and y. Sometimes you'll be dealing with other variables. Now, the x variable has a specific name for it. That is the independent variable. Skip the letter again. Independent variable. So what's the entire set of independent variables that we're allowed to use for whatever we're using here? The range is going to be all possible outputs. Sorry, I just realized my camera was covering part of the words. The range is all possible outputs. And in many cases, those are the y values. Or just using the terms like we did for the previous one, those are the dependent values. Now, again, many times we will be talking about just x and y values, but sometimes we'll be talking about like distance and time, where distance is the independent, distance would be, it could be independent, but typically time would be independent and then distance would be dependent. We're going to get different domains and ranges for those. We'll be talking about like t for time and d for distance. All right. At the bottom here, just kind of a refresher on some of the terminology. We've got different types of graphs here. We've got one, it's linear. It forms a line. Quadratic has that nice U shape, also known as a parabola. Then the higher the degree, the more likely you are to get more and more curves. So, for example, the cubic graph, you can see it's got it's got kind of three different directions going on there. The quartic graph, it goes in one direction, comes back up, 3 directions, 4 different directions. Now, doesn't mean it always will go in 4 different directions, but it can go in 4 directions. Looking at the quintic, goes up, down, up, down, up. It kind of goes in 5 different directions. We're going to focus more on that in a little bit.